Alright, so in this problem, I have 7 to the power of x plus 8 is equal to 8 to the power of x plus 7. So to start, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 7 to the power of x plus 8, that's going to equal 7 to the power of x times 7 to the power of 8. And a to the power of x plus 7, that's going to equal a to the power of x times a to the power of 7. Now I'm going to divide both sides by 7 to the power of 8 times a to the power of x. So then these two cancel out and these two cancel out, and I'm left with 7 to the power of x over 8 to the power of x is equal to 8 to the power of 7 over 7 to the power of 8. Now this is the same thing as 7 over 8 to the power of x is equal to 8 to the power of 7 over 7 to the power of 8. And now I'm going to take the log on both sides. So now I have log 7 over 8 to the power of x is equal to log of 8 to the power of 7 over 7 to the power of 8. Now if I have something in the form log a to the power of b, I can move this exponent b to the front. So this is going to equal b times log a. So log of 7 over 8 to the power of x, I can move x to the power front. So now I have x times log 7 over 8 is equal to log of 8 to the power of 7 over 7 to the power of 8. Now log of a over b, this is equal to log a minus log b. So log of 7 over 8, that's going to equal log of 7 minus log 8, which is equal to log of 8 to the power of 7 minus log of 7 to the power of 8. Now if I divide both sides by log 7 minus log 8, these two cancel out, and now I have x is equal to 7 times log 8, because remember I can move the exponent to the front of both of these, minus 8 times log 7 over log 7 minus log 8. And from here, if you plug in all the values of log 8 and log 7 into the equation, you get x is equal to negative 0.4399. Alright, so in this problem, I have 6 to the power of x is equal to 60. So to solve this, I'm going to first start by taking the log on both sides. So I have log 6 to the power of x is equal to log 60. Now, if I have something in the form log a to the power of b, I can move this exponent b to the front. So this is going to equal b times log a. So in this case, I have log 6 to the power of x, and I can move x to the front. So now I have x times log 6 is equal to log 60. Now I'm going to divide both sides by log 6. So then these two cancel out, and now I have x is equal to log 60 over log 6. Now log 60, I'm going to rewrite as log 6 times 10. Now I have this over log 6. So if I have something in the form log of a times b, this is equal to log a plus log b. So log 6 times 10, that's going to equal log 6 plus log 10. And now I have this over log 6. Now this is the same thing as log 6 over log 6 plus log 10 over log 6. Now log 6 and log 6, these two cancel out. So now I have 1 plus log 10 over log 6. Now log 10, that's the same thing as 1. So now I have x is equal to 1 plus 1 over log 6. And log 6, we can rewrite that as log of 2 times 3. So now this is the same thing as log of 2 plus log of 3. And log 2, that's equal to 0.301. Log 3, that's equal to 0.4771. So x is equal to 1 plus 1 over 0.7781. Now 1 over 0.7781, that's equal to 1.2852. So 1 plus 1.2852 is equal to 2.2852. So this is my answer. All right, so in this problem, I have x to the power of 4 is equal to 4. So I'm going to first start by subtracting 4 on both sides. So then these two cancel out, and now I have x to the power of 4 minus 4 is equal to 0. Now x to the power of 4 I can rewrite as x to the power of 2 times 2, and 4 I can rewrite as 2 squared. Now if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So x to the power of 2 times 2, that's going to equal x to the power of 2 to the power of 2. Now I have this minus 2 squared is equal to 0. Now if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, a is x squared and b is 2. So I have x squared plus 2 times x squared minus 2 is equal to 0. So now this gives me two equations. I have x squared plus 2 is equal to 0, and x squared minus 2 is equal to 0. So for x squared plus 2 equals 0, I can subtract 2 on both sides, so then these two cancel out, and I have x squared is equal to negative 2. So now to solve this, I'm going to take the square root on both sides. Square root of x squared is x, and the square root of negative 2 is the square root of 2 times the square root of negative 1. Now if you guys already know, the square root of negative 1 is equal to I. So I have x is equal to positive or negative the square root of 2i. Now for x squared minus 2 equals 0, I can simply add 2 on both sides, and I get x squared is equal to positive 2. Now to solve this, I'm going to take the square root on both sides. Square root of x squared is x, and the square root of, and this is equal to positive or negative square root of 2. So now I'm going to check. My original equation was x to the power of 4 is equal to 4. So the square root of 2 to the power of 4, because this is an even exponent, it doesn't matter if it is positive or negative, it's going to be the same result. The square root of 2 is the same thing as 1/2, so I have 2 to the power of 1/2 to the power of 4, which is equal to 2 to the power of 2, which is equal to 4. So this works, and for the square root of 2i, it's exactly the same thing. There's no difference. So my 4 solutions are right.